Okay, this video is intended to show you what you're going to need to do in Tinkercad. Hopefully, like, you don't just like copy mine, but to just do it on your own is going to take some effort. So over here, I have the power supply and it's set to 5 volts. If I click on that, it is set to 5 volts, which is what our IC chips run on. And then what I did was I ran power and ground to like this bus and then a jumper across to the other side. I didn't end up using the power on that side, so I can go ahead and delete that. I just ended up not using it. For the switches here, you want to use the slide switch, and the way the slide switches need to be wired up, you're going to take the middle prong and wire that to power, and then take the right hand prong and wire that to ground through the resistor, okay? And that is a 1K resistor that we have there, okay? And that's how you want to wire that. And then basically turning the switch on, you click it. Whoop, don't do that. Oh, it won't let me do it while the simulation is not running. So, okay, so that's how you do that. And then I put like little labels on them. You can do that with this little speech box up here, just so that I know it's like A, B, and C. Now this is where you see that I just am not the most talented at keeping this organized. So here's how the IC chips work. So you need to design your circuit for this activity. You need an inverter, you need a 2-input AND gate, and a 2-input OR gate. Those are the circuits, the chips that you need. Okay, your 7404, that is your hex inverter. Hex just means there are 6 gates in the chip. That's what the hex means. And the number that you're going to do a search for over here, you can just do like 7404 and it should pop up. So you want to know what those names are. The AND gate is a 7408, and the quad just means that there are 4 AND gates in that chip. So if your circuit, this circuit actually needs 4 AND, at least the way I designed it, it needs 4 AND gates in it, and so you're going to use all the AND gates in that chip. And then you also need the OR, and that's a 7432 right there. And you can get that again by just typing in like 7432. And it'll say quad OR gate, just like 4-input OR gate. Now, to wire the chips, it's been a little while since we worked with breadboards and a little while since we worked in Tinkercad. So the if you hover over these, like you notice, like when I hover over a dot, like it or a hole in the breadboard, it shows up like all green, and that tells you what's connected to what. So like that tells me that when I ran power to this hole right there, it powered all of that. Okay, notice that it doesn't go over the divide, and so that's where you have to put your chips, because each of these pins needs to be wired to something, but they can't be wired to each other, and so your chips have to go over the gap there, okay, the ravine, the ridge, whatever you want to call it. Now, to wire the chips up, you have to wire them so that they're powered. And what's nice about Tinkercad is that if you hover over a pin, it'll tell you what it goes to. And so if I hover over this pin in the upper left, it tells me that's power. And then I took a red wire and I didn't run it from like here because I knew that I would have some other wires going in there. So I actually just grabbed it from the hole that's closest to power and just ran a little jumper over. Same for the AND gate and same for the OR gate. There's one chip in Tinkercad where power is somewhere else, and it really fouled people up because you just get used to power being on that pin. And then you'll notice in the lower right, if you have these set up the right way, that's ground. And so I ran a jumper again from the hole that's furthest away, like, and just jumped that over to my ground rail down on the bottom part of the breadboard. Because if you don't do that, none of your chips will work. Okay. Now, in each chip, if you hover over this, and this is where if we were doing a physical breadboard, you would need to pull the pin out. You would actually need to pull the diagrams that would tell you what is each pin connected to. But in Tinkercad, if you hover over each pin, it tells you what it is. So in, whoops, I just dropped my notebook. All right. So if I hover over this pin, it says that is input 1. And an inverter, of course, only has one input and one output. It just inverts a signal. So that's input 1. And then on the next pin, it says output 1. So basically, if anything that you run in here, so you can see this green wire is going from the switch and it's going into input 1. Output 1 is where that's going to come out. And if I zoom in, you can see like I have output 1, and then the output from the inverter is coming over to here, which is input 4A on my AND gate. Okay, so that's how that's going to work. And I think in this particular circuit, you need to invert C and you need to invert B. And so one of these is C being inverted, and then this one is going into input 2, and there's my output 2, and that's the other one. So in this chip that has 6 inverters, I'm only using 2 of them. This is the AND gate, and same deal, like when you hover over them. Now remember, an AND gate, if it's a 2-input AND gate, it's going to have 2 inputs and 1 output. And so if I hover over this, it says like input 4B, input 4A. Those are the 2 inputs. And you can see up here, like here's what's running to those inputs. And then there's the output for that particular AND gate. And then I was running that output, and that output comes into the OR gate at 1B. All right. And so you should be able to like trace that. So there's like 4, there's the output from 4. Here's input 3A is coming in on that orange wire. And oh, sorry, that was 3B. 3A is coming in on that yellow wire, and then there's the output is the purple wire, and that's coming down here. And then this is very poorly wired. You can't, there's a couple things that are really poorly done, but I kind of did this in a hurry just because I wanted to make sure everything would work and to see what I would need to make a video explaining. Like under here, you can tell there's something going on underneath there. There's something going into input 6 and output 6. No, did I have to invert everything? I did have to invert everything. Sorry. We're using 3 of those gates because there's the other one. You just can't see it because it's underneath that wire there. Try not to do that. Okay, and then like you can tell there's stuff happening here. Like when I hover over the pink wire, you can see sort of like that pink wire is going over to this hole here, and it's like underneath the blue one. Generally not considered great. Now, just so you remember, when you're wiring stuff, and I'll do like a quick little wire here, you can place a wire, maybe I can't, oh, I got an anchor right here, and then you can like click, and what I'm doing is I'm clicking, and you can kind of weave it in between stuff, like so. I mean, I don't want that wire there, but you can click and kind of place the wire so that it doesn't like just intersect stuff willy-nilly, and you can keep the other wires visible. So pretty much that's how that works. I wanted to make sure that I showed you the wiring on the switches, and then the power and the ground on the chips, what the chips IC numbers are so that you can look those up. And then when you're wiring up your LED, I tried to flip this around. Again, I kind of did this in a hurry because I wanted to make sure that I could troubleshoot it myself if I needed to. But you need your output, like your final output needs to go to the anode, and then your cathode needs to connect to ground through the resistor. So I have like a little loop-de-loop in my circuit there where the output's coming out of my OR gate. It's going into this side of the LED, gonna light this, and then this is my cathode, and the current's gonna go like back here and then back to ground through the resistor. So you're gonna need to like breadboard this on your own. And then what I want you to do is to simulate it just like you simulate stuff in multisim, except this is simulating it in the breadboard. And then when we get our actual breadboarding supplies, we will physically do this like on a physical breadboard. But for now, Tinkercad will work. So start the simulation, and you do need to test all 8 inputs. So this, I had to do a truth table out for it to make sure that I had it working correctly. But this needs to go high at binary 1, 3, 4, 5, and 6. And it should be low at binary 0, 2, and 7. So this is 0, 0, 0. And then what I do is I click the switch and there it goes on for the 1. Sorry, I got animals. I should kick them out, but I'm too nice. And then I'll turn that one off and then turn on the 2. It should not go on for 2, but it should go on for 3, and the LED does. Now I'm going to bring these 2 back low and turn this one on. It should go on for 4. It should stay on for 5, and it should stay on for 6, and it does, and then it should go off for 7, which it did. And so what I want you to do when you've got this done and wired correctly is do a screencast where you start your switches. So this is in 111, but you're going to come over here and start it in 000 and do just what I did, cycle through the binary numbers and demonstrate that the LED goes on when it's supposed to go on.